All right, and welcome back. So today we are going to be talking about the slopes of parallel and perpendicular lines. We're going to be referencing slope-intercept form a lot today, and we're going to be identifying the slopes of parallel and perpendicular lines, and we're going to be talking about how to write equations that contain slopes of parallel and perpendicular lines to an original equation. So without further ado, let's begin. So two lines are parallel if they lie in the same plane and have no points in common. The lines are never going to intersect. So if you think about train tracks, I think is the best visual for us at least. Train tracks are parallel lines, right? They never intersect, and we hope that they would never intersect or else we'd have a problem. But the train tracks, they go parallel with each other. Those two bars on the outside are never going to intersect. They keep going in the same direction, and they do not intersect. What's important to know here is that we want to have the same slope. So if lines have the same slope, but they have different y-intercepts, then they are going to be parallel lines. So the main idea here is parallel lines have the same slope, but they have a different y-intercept. If they had the same y-intercept, then they'd be the exact same line. So we need to have different y-intercepts, but again, the same slope. So if we were asked to identify which of these three lines are parallel, what we're going to do is we're going to write out the three lines, the three equations that represent each line. So y equals negative 2x plus 4, y equals 3x plus 4, and y equals negative 2x minus 1. We're then going to write out each slope. So we're going to identify the slope of each line. In the first line, our slope is negative 2. In the second line, our slope is 3. In the third line, our slope is negative 2. So far, we have the same slope appear in that first equation, and in the third equation, we have the same slope. You have slope is equal to negative 2, slope is equal to negative 2. So we have to have the same slope in order to be parallel lines, and we have to have different y-intercepts. So again, same slope, different y-intercepts. So do we have different y-intercepts? Yeah, b is 4 and b is negative 1. Therefore, y equals negative 2x plus 4 and y equals negative 2x minus 1 are going to be parallel. And if we graph them, they would look like such, where they're going to be going in the same direction, but they're never going to intersect. The space between them will always be consistent. And that is, again, how we identify parallel lines if we're given an equation. We look for the same slope, but different y-intercepts. We also can determine two lines are perpendicular if they intersect to form right angles. So we're going to identify which lines are perpendicular. The way that we can identify perpendicular lines is by looking at their slope. The product, that's if we multiply, the two slopes are going to be equal to negative 1. So if we take the two slopes and we multiply them, they should be equal to negative 1. If they are, then those two lines are going to be perpendicular. So let's say we want to identify which of these three lines and the equations that represent each line are perpendicular. The way we're going to do that is we're going to look and identify our slope, and then we're going to identify which ones, if we multiply, will give us negative 1. So if we look at 3 and negative 1/3, if we multiply those together, just down here, that's going to give us negative 1. Therefore, the two lines y equals 3x plus 2 and y equals negative 1/3 x plus 3 are going to be perpendicular. There's another way to show it, and it's not written on your notes, but I'm going to write it down here. So please jot this down in your notes. We want to look for the opposite reciprocal. What that means is we're going to be looking for slopes that are opposite each other, meaning one is positive and the other is negative, and the fractions are the reciprocal of each other. So we have to have a positive and a negative. And if we have a fraction, let's say a over b, that should also turn to b over a. If we look at our two examples, or the two equations we identified to be perpendicular in our example, I should say, the second line right here had a slope of 3. Well, that's positive 3. So that's positive 3 over 1. If you look at this second line that we determined to be perpendicular, it's a negative, and it's 1 over 3. Now, to have a product of negative 1, one of them has to be positive, one of them has to be negative. Excuse me. So since that third equation, that third line has a negative slope, second equation has a positive slope, that satisfies the term opposite because one is positive, one is negative. It doesn't matter the order. And the reciprocal, meaning we have the flipped fraction. In the red box, we have a slope of 3 over 1. In the blue box, we have a slope of 1 over 3. So we flipped that fraction. So we can also determine it by finding the opposite reciprocal. Great. Awesome. With this in mind, please work on problems 1 and 2 on the guide notes and resume when you're ready to move on. All right, so we're now on the back of your guided notes, and we want to write an equation in slope-intercept form for the line that passes through the coordinate point 2, 4 and is parallel to y equals 3x plus 2. Let's think back to what it means to be parallel. The slopes have to be the same. The y-intercepts need to be different. So what we're going to do is we're going to find the slope of the line. We can easily identify from the equation, it's in slope-intercept form, our slope is going to be positive 3. We're now going to write the equation in point-slope form. So y minus y1 equals our slope times x minus x1, and we're going to replace our slope, which was 3, the x1, which is 2, and y1, which is 4, and we get 2 and 4 from our coordinate point. And now we're going to write the equation and solve it all the way down to get into slope-intercept form, which is y equals 3x minus 2. Notice now that our slopes should be equal. In our original, our OG, the slope was 3. Notice how in our newly written equation, the slope is still 3. Now again, you do not need to always do in point-slope form. If we have the coordinate point 2, 4, and we have our slope is equal to 3, we can use slope-intercept form to solve for the y-intercept and then piece it all together. So again, slope-intercept form is y is equal to mx plus b. My y is going to be 4 is equal to my slope, which is 3, times now the x value of 2 plus b. When we simplify this, we're solving for b, and we get that b is equal to negative 2. Therefore, when we piece it all together, we get y is equal to 3x minus 2. And again, it's the same thing as we have over on the left-hand side. What is that arrowhead? Wow, that was poorly drawn. There we go. So we still get the exact same equation. Whichever way you go about it, whether you're using point-slope form or whether you're using slope-intercept to solve for the intercept and piece it all together, you should still get the same answer, bearing that you did the algebra correctly. Awesome. So that's how we write an equation that's parallel. Now let's talk about how to write an equation that goes through a point and is perpendicular. So this is on, I believe, on the right-hand side of your guided notes. We're given that we want to have this line go through the coordinate point 2, 5, and it's perpendicular to the given equation, y equals 2/3 x plus 2. So just like we did with parallel, let's think about what it means to be perpendicular. Well, to be perpendicular means my slopes, their product should be -1. And another way to think about it is the slope should be opposite reciprocals of each other. So since we're starting with 2 over 3 is a slope of the original, the slope of the perpendicular line will be -3 over 2. Again, opposite reciprocal. In our original equation, our slope was positive, therefore the perpendicular line should be negative. In our original, the fraction was 2 over 3, therefore in the perpendicular should be 3 over 2. We're flipping that fraction, so we get negative 3 over 2. And then we're going to write the equation in slope-intercept form, in point-slope form, to then solve for our equation, which is y is equal to negative 3 over 2x plus 8. Again, we end up with negative 3 over 2. And we figured out that that slope should be negative 3 over 2, so it should make sense that we end up with the slope of negative 3 over 2. Again, you don't necessarily need to do it in point-slope form. You can use it in slope-intercept and then solve for the intercept. So again, if we're dealing with 2, 5, and my slope is 2 over 3, again, my new slope of the perpendicular is going to be negative 3 over 2, because this is what we call the perpendicular slope. This is actually a way that we can write the word perpendicular in math. We just use it as like an upside down T. So we're going to go to slope-intercept form, y equals mx plus b. We're going to substitute in our values. Y is 5. The slope that we want to have is negative 3 over 2. The x value is 2 plus b. When we solve for this, we get negative 3 plus b. I have to add 3 both sides, just like we're solving an equation. We get that 8 is equal to my b value. Therefore, we get y is equal to negative 3 over 2, x plus 8. And eureka, look at that. It's the exact same equation as we have on the left-hand side using point slope. So again, whichever one you feel most comfortable using, point slope will bring you directly into your answer. Slope-intercept form, as we did on the right-hand side, involves a little bit more work to it, but it's something that you might be more comfortable using. Whichever one you want to use, you should still get the same answer, again, bearing that the algebra was done correctly. Again, a perpendicular slope. Those are opposite reciprocals. So if one of them is negative, the other is positive. And then we flip that fraction. That's where the term reciprocal comes in. So we flip the fraction to get that new slope. Great job, really, folks. Please work on problems 3 through 6 on the guided notes, and please jot down any questions that you have. You're doing really, really well with this. I'm super duper proud of you, and I cannot wait to talk to you soon. Have a great day, folks.